Okay, thanks for joining us in this beautiful morning. No other excuses. Right. Perhaps you guys over there, you could switch on the monitor if you wanted to, if you want to see something. If you don't, that's fine as well. All right, so yesterday I needed to leave in a bit of a rush. Sorry for that again. But Jone took up the opportunity or chance, or what we want to call it, and actually finished up what I would have said. Well, no, he actually went beyond what I would have said in giving you an idea of selected commands. So you learned, understand how to review the software that's running on your system, right? Which command did you use to do that? Which command do you use to check out which packages are running on your Linux system? Yeah, there was something. I heard something. Anyone else? Sorry, I didn't get that.
Running or?
No, not running. No, I don't think you talked about this. Just what's installed. Sorry.
Sudo apt-list.
There you go. Yes, apt-list, right? APT apt. So that's very specific to Ubuntu or Debian-based distributions. If you're running Debian, Ubuntu, Mint, that command will work. If you find yourself using, sorry?
Top as well.
Top? Did you learn about Top? Good. Yeah, brilliant. So you know how to do running programs as well, Top as well. How do you get out of Top? Good, right? So that's an interactive tool, so basically you can have it run in the foreground. Good. If you have other distributions such as Fedora, you're in for a surprise because apt may not work. Or in fact will not work. So you learned about aliases. Briefly, what's the idea of an alias? Yeah, exactly, right? Yes, so you can make your life easier if you have your system, want to customize it. The only thing is there to bear in mind, you're the only person having that command, right? So if you're starting to have somebody else, well, if you're starting using somebody else's machine again, you don't have access to those aliases. That's always be worthwhile, but it's very, very handy to have, especially for the rather lengthy commands we sometimes get. Good. Apart from this, you learned about GitLab and GitHub Markdown, so which is sensible as well. If you need to edit the wiki, please go for it. But you know the syntax right now, so it hopefully helps you a bit. I probably Jone will post his content or the snippets he had in mind for his talk yesterday on GitLab itself, so you can review what he talked about. Okay, coming back to yesterday, so we talked about Linux a bit, the history, so you have some appreciation of where it's coming from. I thought about giving you some mini homework and kind of figuring out some of those commands, because my intent was yesterday that we got as far as to learn how commands generally are constructed in Linux, right? So you have a command, well, the name, you have probably some argument to the command, and then you have potentially options, right? And if you don't know what those options are and how to use them, what can you do?
Most mess up like a help.
Yeah, right. Most of the time it's like -- help. That's the minimum one. That's the easy one. If you want to have a fully fledged documentation, because it's generally available for every tool that you install using apt, then you use man. That's right? So man, space, and then command of choice. Sometimes you need to be differentiate between different sections you want to have a look at. So that's quite sensible. So, and man gives you the manual itself, so it's self-descriptive as well. A few commands. I mean, the slide set is that's a good one. Is it out there? Yes, I think it's out there. Short-term memory. And there are selected commands you want to try out and get to know a bit. If you don't know them, use -- help or use man or things like that, right? So that was the idea, to get an appreciation what those commands are about. Did anyone do it? I can turn around and ask the question again. So then there's no blame. Did anyone? Yes? So anyway, what's cat about? What does the cat do as opposed to dog? Please.
It prints the contents of a file to a screen without actually opening the file.
Correct. Very nice. So it's basically, yes, you basically run the command, it prints off everything that's in a given file on the screen and returns back to the console, right? To the prompt. So you can enter the next command. It's very, very nice if you want to chain commands, right? So you want to spit something out and send it to something else, right? To the printer or whatever else. So you're not in an interactive mode, such as in top in a second, where you need to press Q to get out of it, right? Because dealing in scripts or in automation with interactive tools is incredibly hard. Because there's timing issues, or you just don't do it. It's just not the right way. For example, there are other tools apart from top that are used to, for example, print the current tasks that are running in the system as well. What's the command for that one? If anyone knows.
PS.
PS, right? PS is the equivalent for just spitting out the content that's running, returning back to the command prompt, and then you can use it. And you can pipe it. I don't think anyone, well, we'll get there. So piping is one of the concepts you use. So use the input of one command for the, the output of one command as input for another command. Sorry, please.
I was just wanted to say, like, you can use cat to write directly to a file as well.
Oh, yeah, okay, that's right, exactly. So you can redirect to a file. We'll talk about redirect a bit more after that. So, yeah, there are certain other commands you name. What does that do? And why is it useful?
It's system information.
Yeah, why is that useful?
You can see what distro you're running and what's it called? Number.
Correct, right? So it's super important. You want to know what distro. Yeah, exactly. So version number, the distro you're running on, also the kernel, because Linux. Well, there's of course, if you have a distribution with a given version, there's usually an assumption that there's a certain kernel version sitting behind the Linux kernel. But it's not always true, because sometimes the kernel can be updated independently of the distribution to some extent, or at least if you don't know which kernel a given distribution, let's say Ubuntu 18.04 runs, you can figure that out using uname-a. It prints all system information. So it's seemingly useless, but actually Linux is quite useful, because sometimes you need to know what you're running. If you're running Fedora, you need to use different commands at times. Arch is, that's a straightforward one. Arch. It's straightforward, right?
Arch.
Yeah.
Well, it doesn't work on Arch, but yeah.
Okay. Okay, but what should it do?
It's a architecture.
It gives. Yeah, that's right. Architecture data, right? So that's the idea there. ID user. Did anyone try that one? Well, the easy way out is, of course, of running all those commands. But if you actually want to know what they do, the expectation is that you use help or man. Well, the ID user. Does anyone? In worst case, I fall back to Jona. Please.
Use ID and group ID.
That's right. Heaps of IDs. In fact, all ID association that the user has in the system. The reason why it's important is that in Unix, in an extension than in Linux, everything is centered around IDs, right? We have process IDs, we have user IDs, we have file IDs, we have group IDs, and so on. So it's important what your user relates to, because even though there may be human readable descriptions of groups and names, it's actually a unique ID that's central. Like you guys, hang on, are doing databases? You are doing databases right now, right? Please say yes. I was in the wrong class. Yes. My first response this morning. Brilliant. Collective. Oh, yeah. So you learn about primary keys, right? As unique identifiers, right? And that's roughly the role that IDs have in Unix systems as well. They are more descriptive than users, because file names can change, usernames can change, but IDs don't once they are created. Free. Intuition may help. Free. What does free do? Yep.
Shows the memory, how much is free, how much is occupied.
That's right. Exactly. Right. So you get some overview as well. Another tool again that helps you to do the same thing is, well, not the same thing, but that now that you're talking about memory, it's more talking about disk space, right? Free. As a storage. But memory is in our biggest term anyway. But which tool would you use to figure out how much memory is free? DF, that's the system storage, is right. What I mean, an interactive tool that we talked about before. Or sorry?
HTOP?
Yeah, top or HTOP, right? So top is the standard variant that's pretty much available everywhere. HTOP is the fancy one that is available somewhere, sometimes. So if you know, HTOP is nicer, it has colors and stuff, so that's cool. But fundamentally I do the same thing, that's correct. Who is doing what? What is who?
Prints information about the current and login usage.
Exactly, right?
Terminal.
Exactly, right? So if you need to know who you are, what you're logged on as, and which terminal you're logged on, remember that Linux per definition is kind of a network concept, right? So you have multiple terminals you can connect to. You want to know which one you are on, right? Because you can also interact via terminals, across terminals, right? Very good point. And which is also a good command. The rest I leave for you to figure out. What's which? Yeah.
You wonder where your program is installed?
Brilliant, right? So that's the question I often even got from some of you guys already. Oh, cool, I'm running those fancy programs. Where are they actually located, right? Try run which, because it tells you all locations where this particular command that you're interested in is located, right? So if you run which ls or whatever, right? So that's quite helpful. And there's whoami, uptime, lsblk, it lists your block devices, quite nice as well, so you know what's your storage structure, right? So how many hard drives, partitions, and so on you have in there. Not sure if we talk about this last command, right? So am I wrong? What is last? Fix it. Debug for me.
Should be redirect.
Why don't I know this? Anyway, that's
System boots.
like system times plus system boot. Okay, interesting. WC. Yep,
Word count.
that's correct. What is that? Yeah.
If you enter word count in a file, it will tell you how many words are in the file.
Yeah. It can also be used for what? There's nice options. Yeah. Yeah. Exactly. You most often, if you think about, for example, coding, you want to, line count or line of codes or some of code. Yeah. Then WC-L is a good option to figure out, how many lines of code you have. So it's more common than words, I guess. But so that's a good one as well. Head and tail, they come together.
Beginning or end of a file? Prints it out?
Exactly. It prints the beginning or the end of a file. By default, I think it's 10 lines, right, on the beginning and the end.
Yeah.
But you can parameterize it with -n, so number of lines you want to know. Sometimes useful if you have big, for example, log files. We'll talk about this, perhaps, hopefully. They can be huge, right? They can be 500 megabyte of text file. If you have that catting over your screen, well, you need to wait for a while. And it's not really meaningful. But if you run tail and the corresponding log, you get the 10 last entries. Usually much more meaningful in the context of logs, right? Because you're not interested in what happened last year. You're interested in what happened like 10 minutes ago, right? So tail and head. So.
You can also pass a follow option if you have a library.
Sorry?
You can pass a follow option so it will update and not give the continuity.
That's right. -F, right? Isn't it?
Yeah.
Tail-F follows. So basically, if you want to get a constant update of new entries, then you have tail-F. Problem is, it blocks your console, right? So it kind of sits there. You can't do much other than switching between terminals. Please, there was something.
Just what does W do?
W, say short for who? It's yeah. They have the aliases as well. Yeah, that's the one. Cool. Anyway, that's just a few ones. What I want you guys to be comfortable with, if somebody throws a Unix command at you, and or Linux, you have no clue what it is. You need to be able to figure it out, and also be able to retrace how it's used, or how you could use it potentially, right? So because it's all built in, it's not like Windows where you need to go to Stack Overflow every second. Time you have some sort of question, but actually it's kind of very convenient if you're on the console. Also bear in mind, we're working a lot on the console in Linux, given that this course is more centered around server-side applications. And GUIs are usually not used there for different reasons. I'll let you guess in a second as well. Okay, cool. We have something there. Right, one of the concepts that we touched upon, I actually didn't touch upon yet, is the idea of the super user or root. Does anyone want to give the class an intuition what it is? Because the slides are boring, so I prefer that you guys tell me what it is. Yeah, there's a bit.
Yeah, hold on. What if the super user series they use which can set any permission to themselves?
That's right. That's what I said last year. That's right. I think we briefly talked about this, right? You reminded me. So user and super user. So the idea is that the super user has the right to give himself has the privilege to give himself all privileges, right? Whereas the user has that within certain restrictions, right? So we'll learn how that is restricted for non-regular users. So it's two different things. And the rule of thumb is basically anything that's system-wide that affects the machine, like installing software, changing configurations that are system-wide or network configuration in particular, then you need super user permissions. If it's just changing about the font size in your GUI or your favorite editor of choice, then it's the user level kind of constraint. so users can set it themselves. Again, Linux, and that's the good part about it, that's why it's so incredibly relatively secure compared to Windows. It's really built about multi-user concepts. It's always about having multiple user on a given machine, even though it doesn't look like it, right? Because in Linux, especially in the early days, you used it individually on your Intel 386 or something more modern if you like, but bear in mind it's a descendant of Unix, and Unix was a mainframe system. It was for multiple users. Okay, we have a few commands that we need to bear in mind because they come back all the time. So if we give you commands and sometimes you run them and it says, couldn't find command, right? Command not recognized, not permitted, or things like this. You get this quite often because we sometimes don't provide you with the correct prefix. So bear in mind, sometimes you need to run things as super user. And you have, when you installed Linux, I think provided hopefully, a password anyway that you will need. Because by default, if you're using Ubuntu, for example, your user that you created is a regular user. But this user is generally a member of the so-called sudo group. So meaning it's a user that is allowed to temporarily elevate its permissions to a super user status. So it's not running as a super user, but only executing one command as a super user. So super user do sudo. Yeah. So if something doesn't work, try sudo is a good, debugging strategy. Hence the early introduction of that command. And the syntax is straightforward: sudo space command of choice. So if you have a complex command like complex ls-l/etc or something, just prefix the whole thing with sudo space, and it runs it as super user. Yeah. Cool. Yeah, it may ask you for a password, but that's your user password, right? You just enter your password again as confirmation. Please.
Is there a way to make your user privileged so you don't have to write C?
Yeah. The answer is yes. My question now, is that a good idea? And I bring it back to the class. Is that a good idea to run as super user only?
No, because every process you start has administrative privileges, and you don't want that.
Why?
Because it can do anything without limits.
That's right. You're not constrained doing anything, right? You can delete and I mentioned last time, I think I mentioned that, that if you do something, like deleting something, there's relatively little requirement for feedback. If you say, I'm deleting the root directory and everything below it, it just does it, and then a prompt comes back, and from then on you can't do anything anymore. Perfectly fine. In Windows, again, you would have 500 dialogues warning you, are you really sure you want to do that? In Linux, the assumption is you know what you're doing. If you do it as super user, you easily get into trouble. You delete a directory you shouldn't delete because you're in the wrong location, or you restrict access for yourself. So generally, it's a highly undesirable situation to do that. There's a second aspect to it. You could argue, hang on, I'm on a dev machine, I don't care, right? So I'm using Git, and committing everything. Problem is you still run into trouble because you are ignoring all privilege restrictions. So if you then assume that you run this project or program that you have developed with a lot of care as super user, as a regular user, you'll see you debug your way through privileges all the time, because half the commands you're actually running will not work, right? So it's important to develop as a regular user and to use it as regular user. Only elevate if you need to, not as a general. So that's the difference to Windows world, where you kind of more than not working as privileged user. Comments? Questions?
If you delete something, there is no trash can to get it back.
Very good. I think in the GUIs they have this, right?
Yeah, in the GUI you have it,
Yeah.
but if you RM something, like you remove it in the terminal, there is no control set.
Right.
So
Yeah.
you can install software to give you a trash can in the terminal,
But
but
that's-
by
yeah.
default there's not.
Right. So there's no fallback, right? So if you delete something, it's deleted. No, trash bin like in Windows or whatever else. So it's really, it's for the real user. So that's why you take more responsibility on if you're actually administering or running a Linux system. So you need to be aware of this as well. But again, there's a lot of tools that help you getting it right. And if you don't do anything as sudo, most likely you can't destroy anything system-wide. You can still destroy something user-wide. So in worst case, you need to create a new user account. Surprise. But system-wide not. On that note, I would recommend you, if you want and can, to set up a second regular user in case you delete or deconfigure your first user. You still have one to fall back to. So that's probably a sensible move. because Ubuntu, at least by default, will not allow you to log in as root if you don't activate it explicitly. Okay, the second command. So that's the standard command, sudo, and then the command. So you run as super user. It asks you for password. It does what it's supposed to do, and exits. Right. So let's see if I can kind of demonstrate it a bit so you guys get a feel. And then there's the second command that I typed out here.
It's not on.
Yeah. I'm just trying to bring a VirtualBox thing.
Oh, right.
See if it works. It's probabilistic. I don't hope. Yeah. All right. So the second command that you can try is that to bear in mind, and that's really, really helpful from a practical standpoint. More helpful than the first one. Please come back. There you go. So I'm printing out some user directory or whatever else, right? So and let's see if we can do that on a different directory. That works as well. Good. So what's reasonably forbidden? Let's see if we get there. You should be able to see quite a large number of things. So no, the point is, if you're running a command, for example, ls, and you're printing out something, or make it more extensive content, and you want to run the super user, of course you can run the whole command, sudo ls-lisa, and to give output of the current location and so on. But you can also run, sudo exclamation mark. What does this do? Well, exclamation mark is a variable that indicates last command. So if you happen to, and I will not deconfigure my network now, if you happen to attempting to reconfigure your network and you get some permission error on something, you can just run sudo exclamation mark without retyping the previous command. Especially if it's long and tedious and you have to spend a lot of time configuring, setting it up, you just run sudo exclamation mark, and that's basically a variable for the previous command. So if you run sudo, run it without sudo, it will just show me the same stuff as before, right? Because it's basically repeating the command I ran before. So that's why it can easily combine it with sudo for convenience. So point is, what I get often from people, I hate this, I want to work as super user right now because I constantly run into privilege issues. Well, it's actually in practice not a big deal, because if you get it wrong, you just run double exclamation mark and you'll be fine, right? So you know, what do you think? It's okay, right? It's feasible.
Sure.
Sure. Okay. Good. You don't just say it because I say it, right? All right. Sure. So much about that. Okay, super user. So it's quite important to get that right. So generally, Unix is reasonably permissive with users looking at stuff. It's not so permissive with users changing stuff. So if I want to see the configuration directory and so on, that's relatively straightforward. If I want to change anything in there, however, that's quite a different beast. But we come to privileges in a bit. So that's the most important thing, because you'll run commands that require you to access locations, write most likely, to locations which you otherwise wouldn't do. Okay. One thing I spend a few words on is the virtual file system principle. So in Linux, again borrowed from the Unix metaphor, nearly everything, few exceptions, nearly everything is modeled as a file, or in many cases. So actually you're reading from files, writing from files, and so on. And that's following basically the object-oriented paradigm or metaphor. But it also is quite interesting because even devices or processes are represented as files. That's weird, right? So the idea is that you can interact with devices by identifying them in the file system. So there's no abstract other way like in Windows where you need to identify resources perhaps via device manager or the like, but they're actually files. And that's really, really, really nice, because you just need to understand the file system, and then you pretty much understand the structure of any Linux system anyway, but you also know where to look for devices. How practical it is, good question, but nevertheless it's worthwhile noting, for example. So if I'm, for example, in the proc directory, hang on, let me try that again. Proc, yeah, if I get it right. PROC. And you may not be able to read it, but the point is, what it does here, it's printing me out all kinds of processes that are actually running in the system. Here, there you go. So I'll do it differently. You learned about top yesterday. That's this tool here, right? So it runs something and shows you the currently executed command with priority. And in the front left, you see something like PID. Yes, you do. That's the process ID, right? So that's the current process ID of the process running. And you also see who ran it. So you see a user column, and it contains a user entry and root entry. Root entries are programs that are basically tasks that are run by the kernel itself. Most likely related to system services, but also drivers. For example, you have things like the crypto service running there, SCSI, which is about device storage access, block storage access, and threads, and so on. And then you have all those user-started processes. That's the stuff I started as the user. Okay, and on the far left, you see the PID. And this concept is precisely the same as you would find here. If you see here, I just did an LS, so list content of the proc directory. You see a lot of those IDs, and those are actually pointers to the processes. So you can indirectly interact with processes via this file system. It's kind of a weird concept to get your head around, but you get comfortable with this. We don't use it terribly often, but I think it's worthwhile to know because it's sometimes it's interesting because you can read process data, for example, or use it for debugging purposes. Okay, right, file system. Since we're talking about file system, there's one thing we kind of all need to share and know. That's the file system hierarchy standard, FHS. And of course, it's important, first of all, to know where files are, but also to kind of know every Linux distribution. That's the idea. So make it as general as possible in this course. So hopefully you can take something away, even if you decide to explore different flavors of Linux eventually. All right. So what do we have? Well, it's largely borrowed from the original Unix standards, in fact, and everything in the file system or in any given system, there you go, starts with root. And that's in this case root, not root the user, or super user. Root is the same there, by the way, in terms of terminology when it comes to user, but also the root directory. That's the root in the file system hierarchy, right? So the top level, that's just slash. If you want to be in the top of the file system hierarchy, just run slash. So if I do that right now, I'll just say ls slash. Let's list that a bit nicer. Right. So I ran, you may not be able to read it, ls-lisa. I'm going into the lisa eventually, and then slash. So please show me the root directory. And if you look carefully, the structure you see is roughly, I'm saying roughly intentionally, roughly the structure you just saw on the slide set. You have bin, boot, CD-ROM, yeah, okay, I don't know what that is anymore, dev, etc, home, lib, and so on, right? A lot of those different directories. They're very slightly per distribution, but they're reasonably uniform there. So you can access that as well and have a look at it if you want to. But let's iterate through some of those locations because they're quite important for you to understand where things are in your system. So generally, we differentiate between aspects that are user installed and aspects that are system provided but accessible to the user. Most commands that you use on a common basis on every Linux system, such as ls and many of the other commands we just iterated through in the beginning of the session, are actually situated in the bin directory. So /bin binaries. That's where the user binaries are. The idea is that the user should be able to access them commonly. Don't use them. So you can do an ls there, and you see a lot of those commands that you will use over time in that directory. The boot directory is basically location for different, for files related to the bootloader. So in Linux, when you boot, you don't see that when you run Ubuntu, but generally, if you run it console only, you get a 2 seconds or so delay. Oftentimes, you see some bootloader and gives you several options. And what often happens there is that you can run different versions of the Linux kernel. Some are more, perhaps more recent. Some of them are more experimental or for debugging purposes, and some are more stable. So you can in principle choose, and the different bootloader files related to actually starting different kernels are lying in this boot folder. Point is, you don't need to worry about this folder, right? So in practice, not really relevant, but if you ever need to look into the direction, okay, which the kernel I'm starting and where are those files, that's the location, yeah? So then we have dev. That's the device-related files concept. As I just mentioned before, nearly everything, there's few exceptions, like network cards are not represented there, are represented as a device. That includes, for example, a pseudo random number generator, hard drives, of course, keyboards is represented there, mouse is represented there, CD-ROM, things like that, DVD. Yeah, CD-ROM. I will not get over that. Are represented there, of course. Terminals as well. So if you have multiple terminals, you'll also find them in there. And when I talk about terminals, I didn't mention that before. Probably need to make that more explicit. Let me go to a more ancient virtual machine. Because it's important to understand that something is very uncommon to system to Windows users in particular. Second. So I'm running a some Linux system here, but if I want to, let me just exit. No, that was wrong. So I'm running an Ubuntu 16.04.3 LTS. Really old, doesn't matter. Current LTS is 18.04. I'm just showing it because it's console only. This is the LTS systems, especially on server side. Oh, sorry, Ubuntu server distributions generally don't have a GUI installed. You will need to install it manually. For this course, we offered you to use the desktop version, so we have a GUI installed. This one is GUI-less. But the point is, if you use Alt F1 to F6, you can actually iterate through different terminals. You may not see that, sorry for that, but there's a small, tiny TTY at the end of the first line in that console window, right? TTI1. And you can actually flick between TTI 2, 3, 4, 5, 6, and that's it roughly right now. But the point is, you can actually log in multiple terminals at the same time. So it's quite nice. So if you want to do something in the background, you want to look at processes in one file, and the others you want to edit a file, or you want to look up something, you can easily do that by switching around between all the different terminals and using them completely independently, right? So and when one terminal can do something else, the other one I can run, for example, top. And that's then very easy for me to switch around. And I still have 4 other terminals I can use. Again, it boils down, it comes back to this concept of multi-user use, even on one single machine, which is pretty cool, right? So it's something we don't have easily in Windows. So if you can try to use that, especially running the server-side systems. So it's a quite neat concept. And those terminals, TTY, you can actually find them in the device directory as well represented. So if I'm going to cd def, cd change directory like Windows, you guys are comfortable with Windows commands, right?
I know about CD.
Yeah, cd is good. I think it will do. So for now, let's hope it will. If we run ls here in this example in def, right? I changed the device directory. You see here, there's actually TTY 0, 1, 2, 3, 4, 5, and so on. In fact, there's a nearly endless list of different TTYs because there's no presumption as to whether you connect locally or remotely. But only the first 6 ones are actually bound to the interface windows that you have. Cool, so much about this. So I just wanted to get that across since we're talking about this. Because those are all the aspects that can be quite useful for you as developers later on. When you're developing, you want to look something up while coding, or you have issues with sudo, you know how to take shortcuts and doing things like that. Okay, device directory. Then we have the etc directory, very important one. All system level configuration, host specific configuration, is situated there. Network configuration. Configuration for most of the tools you probably install. If you have a desktop system installed, the configuration files will be found in there. Of course, networking. What else? Host name. What else do we have in etc? Heaps of stuff.
Question.
Sorry, yeah, please.
If you have multiple users
Yep.
logged into a server, can you use the who command to see what kind of session they have?
The who command doesn't spit out the. That's a good one. So yeah, it does. Yeah, right. Yes, you see it. You can see it, user, and then the TTY is connected from. But again, it shows you all logins of a given user, right? So if you are logged in twice, as you are here, or as I am here, TTI1 and TTI6, You see both. That's right.
Well, if you have different dishes, it would show. See.
Really? Really? Come on. I just create a user and it can't log in. That's sad. This is sad. I've mistyped the password there. Let's see. Where am I? Shadows. No, I don't need this. I need this. Yeah. Cat. Let's see. Pass D. Created a user. It's called test, and it's supposed to be able to log in. Anyway, I'll take this into break and figure that out in a second. Do you guys want to have a bit of a break before we continue? Yeah, you seem okay. That's the 9:11 kind of phase, like as in 9 o'clock 11 kind of phase, not the other 9:11. Cool. We meet back here at what about 20 past? 9 minutes of break is enough.
Yeah.
Good. Thank you. That's an interesting problem here.